Okay, I kind of cut that last one off a little bit early. So here's what we're going to do. We're on our that I don't want to get too far ahead, but um, and I'll get back to your pre-lab here in a second. But here's kind of the part of the lab that you'll be doing is you will measure your R, and that's going to be kind of tricky to do. You know that so I want you to give a few sentences as you see on the lab sheet. I want you to give a few sentences on how you went about doing that, how you found your R, um, and we're going to find the lift coefficient is what we're going to do. And from the soccer videos, you saw that there is a Magnus force which pushes the ball. So, and then here's what your experiment looks like, and we'll get to this slide in a minute. This is very busy. This is not your build your own boomerang. Here's a boomerang you can build if you want, but I prefer just this one. So what we're going to do is we're going to measure I, A, and R. Uh, I don't know what A, oh, the area, and then we're going to calculate CL. Hold on. Assume air is 1.2 kilograms per meters cubed. I don't know what the A was. I think that was a mistake. Oh, it's supposed to be I and R. Measure I and R. And we'll be using this boomerang. So let's go look. Let's go look at the pre-lab some more. Okay. So we've looked at these things. I just told you the Magnus force. Um, we want to find what is it, over the next two problems. We're going to compute the Magnus force of a baseball pitched. Okay, the Magnus force is given because you're going to have to do this. This is kind of get you in practice for doing your calculations. Okay, so the Magnus force CD um, is the coefficient of drag times the air resistance times the diameter cubed times the frequency. That's how fast the ball is spinning, and times velocity. Okay, and then so what is CD? Coefficient of drag. Okay, do the due to the acceleration due to gravity, a skydiver will pick up speed until he or she deploys their parachute. This is out of order. Is that true or false? No, it's false. Right. We are pros to this by now. What is 93 miles per hour in meters per second? So I need to rearrange. All of a sudden, this one's like in the middle of all this. What is D in this problem? So I'm going to have to adjust this. In fact, I'll do that right now. No, I don't want to do it because then you all see the answers. So I'll make sure I fix that. So this isn't going to be stuck. This question 7 is not going to be stuck in the middle there. All right. So compute 93 miles per hour in meters per second. What does that look like? So you got 93 miles per hour. Now remember, some of these questions are from my physics of sports, so they are experts at this time. 93 miles per hour into meters per second. You can go to Google if you want, or you can just go 93 times 0.447. That's the factor that you multiply by, and that'll give you the answer in meters per second. Okay, because this is 1609 meters per mile. So the miles cancel divided by 3,600 seconds per hour. So your miles per hour cancel. And you left with meters per second. What's D? V is for velocity. F is the frequency. It's 27.5 revolutions per second. Oh, reaction time. What is P? For our problem, it is, which is it? Density of the ball or the air? Right, the air. Put it all together, and you'll find the Magnus force. Okay. Now remember, with that D cubed, that's going to be kind of tricky. So you can take the diameter. Did I give you the diameter of the baseball? Yeah, 6 points. Now remember, you got to convert this to meters. Don't forget to do that. Convert that to meters. All right. Jump Red Bull from how high? Think 39 kilometers. Whoa. How many miles per hour is that? Question 16. All right, I'm going to go ahead and stop this right now. This is 11, I do believe. What are we doing here? What are we? Yeah, this is 10. It's almost ready. 9 I've already loaded. Okay, so let's do 10. All right.